Hello everyone, my name is Rahul Kulkarni and I've performed analysis on the airline dataset. So this is my project for the AIT 5T2 subject. So initially for the introduction here mainly I have chosen this dataset and I have kind of mainly analyzed this as a data scientist for airline A, wherein I kind of see the factors which are affecting the customers who are flying with airline A or the customers who didn't choose to fly with airline A, and also help to increase the customer base for this airline. And here our data science team is kind of mainly hoping to identify the important factors which will help the advertising team in kind of attracting more customers. So coming to the data set here, this data set is mainly in the JSON format, and it mainly has 6 different attributes which are the fare, guests, seat class, success rate, age and gender, and there are totally 891 records. So we can see have given the explanation of each attribute here. Customer ID refers to the unique ID of the customer. Success rate tells us if the customer who booked the flight, did he choose to fly with this airline or he didn't fly with this airline. And also description attribute kind of tells us the different details about the customers, like his name, age and other factors. And coming to the seat class, there are 3 different seat class, which is seat class 1, 2 and 3, and the customers can choose seat class based on this, and they can book their flight here. And coming to the guests, so if the particular customer who booked the flight, did he have any guests with them, so this will give that information. And finally fare, which will tell the cost, the total fare pair, or the cost of the airline ticket. So coming to the data set here, we can see that this data set mainly is in the JSON format, and one of the challenges I had was that I cannot perform any data analysis using this JSON format file. So what I had to do was I had to mainly convert the data set into a CSV file or comma separated file, so that I could easily perform data analysis and interpret the data in a better way. Mainly have used here is Python programming and various different packages such as Panda, NumPy, Seaborn, Matplotlib. So yes, so what you can see here is the Python schema or the structure, wherein I have converted the JSON dataset to a CSV file. It's a very easy step in Python. So this dataset, sample of this dataset mainly shows us that the original dataset. So this is a dataset which has not been cleaned, or there is no data extraction. As you can see in the description attribute, we have the first name, last name, and the age of the customer merged in one column. So we kind of have to extract this dataset and kind of put separate fields for the age and name as well. So let's go ahead. So mainly here performing the data extraction, metadata extraction. So we from the description field, as I mentioned, we extracted 2 main fields, that is age and the gender of the customer. So after we kind of extracted the metadata information, we appended 3 different files, which is the age, very important attribute for the dataset, and the gender, and also the title of the customer. So yeah, and one observation which we saw was that age attribute has many number of missing values. So this would pose a big problem for further analysis, because if the dataset has missing values, we really cannot perform any data visualization or data analysis. So first we had to make sure that we kind of impute the missing values of this data, and the best technique which I found was the median imputation. So I kind of took the median of the age field and imputed the data. So this data set you can see here is after a median imputation. So as you can see in the age field, there are no missing values. So this is a very clean data set and ready to perform data exploration and further data analysis. So here there are two different diagrams. This is the histogram diagram. So the image one on the left, which is the figure one, shows us the histogram of age field before data imputation and before data cleaning, and the figure 2 shows us the age field after data cleaning. So when we compare these two diagrams, we can see that there has been a reduction in the skewness in figure 2 compared to figure 1. So yeah, this was the difference which I saw. So also I found another way to kind of perform imputation or to get rid of the missing values was the z-score normalization. So here we have performed this z-score normalization on the age column, and as you can see, I've also shown the formula as to how I did the z-score transformation. So here I have calculated the skewness of the data set. So I have and the formula given here, skewness is equal to 3 of mean minus median divided by standard deviation, and I've got all the values for the skewness from after taking the summary of the z-score value, which you can see on the left bottom corner. Yeah. So so what I concluded was from the image that this is a left skewed histogram with the skewness value of 0.024. So coming to one of the very interesting part of our project, which is metadata exploration or data visualization. So this has given me like a lot of different insights as to how it kind of affected the customer base. So so the two of the main attributes for which I have kind of done the analysis is the gender and also the count of the data set here. So the success one refers that the customer who kind of booked the flight and successfully flew on the book trip 1, and success 0 refers that the customer booked the ticket, however he didn't fly with this airline. And also based on the analysis here from the visualization, I concluded that the number of female customers successfully flew on this book trip 1 when compared to the male customers. And also one more analysis which I found was the number of male customers, as you can see on the left side, the big purple block. These are the number of male customers who booked this airline but didn't fly with this airline. So this is one of the analysis which I did. This is another metadata exploration wherein I have taken the seat class, there are 3 different seat class against the number of count. So to see how many number of customers have booked particular seat class. So as I can see that seat class 1 is where the maximum number of customers flew with this airline. But also another analysis I did was for the seat class 3, there are maximum number of bookings, but these customers didn't really choose to fly with this airline. Another visualization is for the guest parameter. So what I analyzed was guest 0 refers that the customer is flying alone, guest 1 refers that the customer is flying with one guest, guest 2 refers that the customer is flying with 2 guests, and so on up till 8 guests. So one main analysis we can easily see from the diagram is that the customers with no guests had made the maximum number of bookings, and also they are the number of customers who flew maximum compared to the other parameters. Coming to our 4th milestone, which is a very important aspect of this project, is attribute preparation and engineering, mainly in the VCA software. So here what I've done is I've mainly chosen 6 attributes, which is fare, guest, seat class, success, age, and gender. And also I've removed few other attributes which I thought was not useful, was customer ID, description, last name, first name, and title. So here you can see the data visualization for all the 6 attributes, that is fair, guest, seat class, success, age and gender. All the visualization are very clear and accurate. And also one other thing I did was I converted the numerical value to nominal value, mainly for the success attribute, wherein the success 1 is converted to yes factor and success 0 is converted to no factor. So I converted it to numerical to nominal value because I could perform the analysis easily. And also, since the success attribute is the target attribute against which all other attributes will be measured in the Vika software, I thought it would be much easier to perform the analysis. And also I saw that there are 549 attributes for the success attributes wherein the customers chose to fly with us, and there are 340 attributes or customers who after booking the flight did not fly with us. So coming to the next part, wherein I have performed the attribute evaluator to kind of mainly see which are the top attributes for this data set, or which are the top attributes which are affecting the customer base of the data set. So here I performed the InfoGain attribute evaluator. So as you can see, and I also have set the search method for ranker, and the cross validation is k is equal to 10 folds and the seed is set to 2, and you can see it is measured against the success attribute. So from the diagram we can analyze that gender and fair are the top two attributes for this data set. So next I also perform another attribute evaluator, which is the gain ratio attribute evaluator. So here also I have set the cross validation for k is equal to 10 folds and seed is equal to 2, and measured it against the success attribute. So here also I could easily analyze that gender and fair are the top two attributes for this evaluator model as well. So coming to our major part of the project, wherein building the predictive models. So I have mainly built 3 predictive models, which is the decision stump, J48 model and also random forest model. So decision stump mainly is about is a machine learning model which takes only one input feature. So as you can see here that the cross validation is set to k is equal to 10 folds, and the accuracy which I obtained was 78.45%, precision was 78.2%, and area under the curve was 74.44%. So the diagrams which you can see is the top right corner is the model which I ran, and the bottom right corner is the ROC curve model. The second model is the J48 model, which you can see, and which is a ID3 algorithm which has used that, and it kind of takes some of the best attributes to perform analysis. And here the accuracy is set to 80.35%, precision is 80.2%, and area under the curve is 81.9%. And also you can see the analysis performed on the right and ROC curve on the right as well. Coming to one of the very good models, which is the random forest model. So this model basically kind of takes many number of decision trees and performs the analysis. Here also the cross validation is set to k is equal to 10 folds, but the accuracy what I got was a very good accuracy, which is 81.03%. Precision was 80.9%, and area under the curve was 85.34%. So also you can see the diagrams. The one on the right corner is the analysis, the random forest model, and the below diagram is the ROC curve diagram. So coming to the conclusion part, we can mainly analyze that I have performed 3 different models, which is the decision stump, J48 and random forest. And also the best model which I found was the random forest model, which had an accuracy of 81.03%, and the precision was 80.9%, and area under ROC was 85.34%. So also I have performed 2 main attribute evaluators, which is the InfoGain attribute evaluator and also gain ratio attribute evaluator. And in both these evaluator, I got the best 2 predictors for this data set to be gender and fair attributes. And one of the best imputation technique I found was median imputation, which I performed on the age attribute. And conclusion from the visualizations, what I understood was there are a maximum number of female customers who successfully flew on this trip one compared to male customers and all, but there were more number of male customers who booked the ticket on this airline, fare on this airline, but didn't fly with this airline. And also the highest seat bookings was done for seat class 3, but the maximum customers who had booked tickets on seat class 3 really didn't fly with this airline. We can also analyze that when we compare seat class 2 and seat class 3, the maximum number of customers who flew with this airline was seat class 1. And concluding that the customers who are traveling alone were in maximum number compared to the customers who are traveling with guests. And also from this analysis we could kind of conclude that the success rate is high for customers mainly who are traveling alone compared to the customers who are traveling with guests.